Hello, my name is Amir Amili Razik bin Azmel. I'm a second presenter of this group. I would like to present about exercise short transmission line. So from this exercise, I put the VRLL is 220 kilovolt as we get in the lab. So next, for the VR, calculate the VR by using a VRLL value divided by square root 3. So this is the program. After that, calculate the Z by using a series impedance per phase. So Z is equal to 0.15 plus J times 2 times Pi times 60 times 1.3263 exponent power of 3 times 40. After that, display a statement for a power factor lagging by a value of a A. So for the calculation, calculate the SR by using a appearance power formula. For the question A, SR is 304.8 plus J times 228.6. After that, IR is equal to CONG SR over 3 times VR. So that is calculate IR by using a current per phase formula with VR value. After that, calculate the VS by using end of voltage formula is VS equal VR plus Z times IR. So next, calculate the VSLL by dividing square root 3 with absolute VS. So the formula is VS LL equal to square root 3 times ABS VS. Next, calculate the SS by using sending end power 3 phase formula by using a value is IS and VS. So the program is SS equal to 3 times VS times IS. After that, calculate the regulation by using a voltage regulation formula. Reg is equal VSLL minus VRLL divided by VRLL. Next, calculate EFF by using transmission line efficiency formula. So EFF equal real SR divided by real SS. Next, display for part B. So the question for B is calculate SR by using appearance power formula. SR is equal 304.8 minus J times 228.6. Next, calculate IR by using a current per phase formula with a VR value. IR is SR divided by 3 VR. After that, VR value IR that has been calculated is equal to IS. IS is equal to IR. Next, calculate the VS by using end of voltage formula. VS is equal VR plus Z times IR. Next, calculate the VSLL by using dividing square root 3 with absolute VS. So VSLL equal square root 3 times VS. Next, calculate the SS by using ascending power 3 phase formula by using a value of IS and VS. So the program is SS equal to 3 times VS times IS. Next, the calculation of regulation by using a voltage regulation formula. Reg equal VSLL minus VRLL divided by VRLL. Okay, next, after run the program, at the command window, for the the display for the A power factor lagging VSLL is equal to 250.0186 volt. So for the SS, answer is 3.2280 exponent plus 02 plus 2.8858 exponent plus 02i. So for the regulation is 13.6448% and for efficiency is 94.4252%. Next, for the B, the power factor of leading, the VSLL is 210.0884 volt. For the SS, answer is 3.22080 exponent plus 02 minus 1.6862 exponent plus 02i. For the regulation is negative 4.4144% and for efficiency is 94.4252%. Alright, Assalamualaikum warahmatullahi wabarakatuh. My name is Amir Amdi Razik bin Azman. For the short transmission line in a manual solution is for the A, the series impedance per phase 2 equal V plus JWL times L. So from the equation given, we get the answer is 6 plus J20. So next, for the receiving end voltage per phase, that means is we must to calculate of the VR. So 220 0 degrees divided by square root 3. So we get the answer is 127.0 degrees kilovolt. So for the appearance power is SR is 318 cos negative 1 0.8 equal is 318 56.87 degrees. So the answer is 304.8 plus J228.6 millivolt. After that, for the current per phase is given by IR equal to S times R divided by 3 VR. So we get 1000 negative 36.87 degrees ampere. So from the sending end voltage is VS equal to VR plus IR. So we get 144.33 4.93 kilovolt. So as we can see for the VSL in a program, we get 250 kilovolt. Then for the sending end power is SS is SVS times IS. So we get 433 41.8 degrees millivolt. So for the regulation percent of VR, the equation is 250 minus 220 divide 220. So for the percent, we must do times 100 and we get 13.6%. So for the efficiency is PS over PR over PS. So 304.8 over 322.8. For the percent, we must do times by 100. So we get 94.4%. So the question for B, the current for 381 millivolt with a 0.8 leading power factor. IR is 1036.87 degrees ampere. So for the VSLL, we get a 210.26 kilovolt. Then for the voltage regulation in percent, we need to put a 210.26 minus 220 divide 220. So for the percent, we must times by 100, so we get a negative 4.43%. And finally, for the efficiency, PR over VS, we get a 304.8 divided by 322.8. For the percent, we must times by 100. So in percent, we get 64.4%.
Okay, hi, Assalamualaikum. My name is Intan Azina binti Jamaluddin. My metric number is CE2200. Today, I would like to present for the medium transmission line. So first, we calculate the value of inductance, capacitance, and resistance. The value of inductance, we get 1.29 millihenry. For the capacitor, we get 0.009 microfarad. Resistance, we get 32 ohm. After that, we get the value of X, Y, and Z. The value of X is 81 ohm. The value of Z is 87.1, angle of 68.4. For the value of Y, we get 0.00056, the angle of 90. The value of X, Y, and Z is the constant impedance. More for the value of A, B, C, and D is the median transmission line by nominal T method. Value of A and D, we get 0.973, angle of 0.5. B, we get 86.4, angle of 68.6. And value of C, we get 0.00056, angle of 90. Other than that, we also find out the value of I reactance. The value of I reactance, we get I reactance is the current reactance, we get 0.2734, angle of negative 36.9 kiloampere. The value of voltage reactance, VR, we get 76.21, angle of 0 kilovolt. For VS, we get 65.52, angle of 7.5 kilovolt. After that, we also have to find the efficiency of transmission. Efficiency of transmission, we get 88.5%. And lastly, for the percentage of regulation, we get 100.32. Lastly, for the percentage of regulation, we get 28.15%. So we continue with the coding of medium transmission line in MATLAB. We use MATLAB to solve this coding. From our coding, we get the length. From our coding, we want to get the medium transmission line by nominal T method. After that, we want to generalize A, B, C, and D constants are. that, we also want to figure out the sending end voltage Vs, sending end current Is, and the voltage regulation Is. After we click on the run button, the result will display on the command window. First, the result wants us to enter the length of line in kilometer, receiving voltage in kilovolt, power in microwatt, power factor, inductance, resistance, capacitor per phase per kilometer. Okay, first we have to enter. Okay, as you can see, this is the value of the generalized A, B, C, and D constant R. We also get the value of sending end voltage Vs is, sending end current is, voltage regulation, and lastly for the efficiency is 88.519920%. Okay, finally we can get all the value that we want. And lastly, as you can see, by comparing the result of our manual calculation and our simulation in MATLAB, we can see that the efficiency of transmission is 88.5% on MATLAB, and on the manual calculation is also 88.5%. That's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Abdul Sabiq Muhammad Ramli. So now I present this exercise. So this is the coding that already is being given in the project in the lab report. So this is the coding that I already put in MATLAB. So as you can see, this is the one that I use. This is the coding that I use. After that, we need to run it to get this. So to get this value, it need to be according to this table. So first of all, we need to put the number of buses is 3, and then number of pins is 3, and number of starting bus 1, 2, and the first one is 0.1 plus 0.3J. So the charging admittance is 0.02J. So starting bus, so we move forward to number 2, receiving bus number 3, and the impedance number is 0.15 plus 0.5J. After that, 0.0125J, and then at starting bus number 3, receiving bus number 1, and the impedance 0.2 plus 0.6J, 0.028J. So this is the matrix that already been calculated. So to prove this value, I already do the manual calculation for this. So according to the manual calculation, it has been proven that this coding is correct and the input is also correct. That's all from me. Thank you.